Alright, so the first type of circuit that we're going to look at is a series circuit. And a series circuit is determined by how you connect the resistors together. So if we have a resistor here and a resistor here, see how we just call them in series because they're just one after the other. And one of the features of a series circuit is the current remains the same all the way around the circuit. So if we have a current here of 2 amps, and the current here is 2 amps, the current here is 2 amps, the current here is 2 amps, and the current here is 2 amps. Okay, and if you remember V equals IR, if we've got and R equals V over I, if we've got 12 volts here and a current of 2 amps, it means that the overall resistance of this circuit is going to be 6 ohms. And if you add 3 ohms plus 3 ohms, that gives you your 6 ohms here. So when you have resistors in series, then you can just add them together to give the overall resistance. Same over here. If we have 2 amps here, then 2 amps is going to be there, there, and there. And as you see, we had like 3 ohm resistors here, 2 of them, and that add up to 6. Here we have a 2 ohm resistor and a 4 ohm resistor, which also adds up to 6. So overall, the resistance would be 6 in this circuit, and that's how we get our values of current and also voltage. Okay, so voltage divides. So another feature of this circuit. So I'll just talk a little bit about voltage. So if we have a battery of 12 volts here, it means that all along here, or there compared to there, there's going to be a voltage drop or a voltage difference. Remember that voltage is the difference in energy between 2 points. So we're going to have a difference in energy between those 2 points of 12 volts, which means here and here, there's also going to be a difference of 12 volts. Now, I'll just get a different color here. Well, maybe not. If we look across at these points here, let's say we went there and there, see how it says here, there's an energy drop of 6 volts. Okay, so if there's an energy drop of 6 volts from here to here, and there's a total drop or difference in 12 volts there, then there must be also a difference of 6 volts across here. Alright, so 6 volts plus 6 volts is equal to 12 volts. If you wanted to calculate these values, if we label this one R, oh, gee, my elbow just slipped there. Let's get rid of it. I don't want to get rid of all that. Oh gosh, look at that. It takes us up there. That's interesting. I'll see if I can just get an eraser onto that. Let's draw an eraser. Yeah, okay. Put my pen back. Okay, good. So let's now label this one R1 and this one R2. If we were to calculate, there's actually an equation. So if we want to calculate V1, we could use R1 over R1 plus R2, and we times that by the voltage in, or the total voltage, which would be the 12 volts. If you wanted to calculate V2, so the voltage drop across the second resistor, it's pretty much the same formula, just R2 goes on top there instead of R1 times the voltage in. Okay, so these equations here, you don't actually need to know these for this course. We're not going to do any calculations with them. But if you just wanted to have a look at, or just wanted to check your answers or something, if you want to do some maths on these, then you can do that. So if moving on to the next one, we have 12 volts drops here. So there's a 12 voltage difference over here and all along these wires here. And we have 4 volts here, so we have an 8 volt drop across here, because all of that from there to there is a drop of 12 volts. And you could put those numbers into, so you have 4 where R1 is and 8 where R2 is. And look what I did here. R2 is there. Okay, so, and it's all about the ratios. So see how if we have 300 here and 600 here, there's a 900 total. So you expect that there's going to be a bigger drop across the bigger resistor, and see how the resistance here is twice as much as this one, so our voltage drop is twice as much as this voltage. So the 8 volts is twice as big as the 4 voltage drop, or 2/3 of the voltage is dropped across the 600, and 1/3 of the voltage is dropped across the 300 there. Alright, it's doing its non-responding thing. And you can probably guess then for this last circuit here, if we've got a 9-volt drop across the first one, we've got a 3-volt drop, and again, it just is going to, there's 600 is 3 times as much as 200, so 3/4 of the voltage is going to drop across a 600 ohm resistor compared to a quarter of it dropping across that 200 ones. So calculations in series. So basically, this is just doing the maths for what I just described then. The total voltage, that's the total voltage across there. So this total voltage is going to be the sum of this voltage plus this voltage, so V1 plus V2. Basically, all that's saying is that the voltage drop from this point to that point is the same as the voltage drop from that point to that point. Okay, and you get a voltage out there. And the resistors, the total resistance of the circuit for a series is equal to the sum of those resistors. So if we were to draw a diagram for and calculate the resistance of 220 and 470, we might have a battery, and we can just use the 2 bars there, and I might as well do the other type of symbol for resistance. So that's also a symbol for resistance or resistor, and this is 220 ohms, and this is 470 ohms, and so our total is equal to 220 plus 470, so the math is quite easy, 690 ohms. And we'll look at parallel resistors next.